Hello. So the next step in our Python journey is Module 8, and this is about modules, packages, and file operations. One thing we can do once we've figured out how to partition the code, like we talked about in Module 7, Object-Oriented Programming, is how do we structure larger code bases? And the way Python uses this is through modules. And I'll give an example shortly about how some parts of the midterm might have been able to be done a little differently had we known about modules before the midterm. Okay, so what are we doing here? We're going to describe what they are, what packages are, how to work with built-in or pre-existing Python packages, and then we're going to talk about how to deal with file I/O using Python. So a module is any file in Python with a .py extension. It can contain any valid Python code, and it can go into a directory containing, or it can be a directory containing many Python files. If you do have a directory containing many Python files, it's good practice to include an _init__.py file inside that directory, and that module can then be imported using the import keyword somewhere else in your program. And all a package is a collection of modules. So that could be a collection of .py files, or it could be a collection of directories of many py files per directory, or it could be directories of directories of directories, etc. Right? So it's Python all the way down. So modules can contain any valid Python code, variable definitions, functions, classes, methods, whatever you want. So you make the file called module name.py, and the module naming convention is that we use snake case, we use descriptive names, and we only use underscores to improve readability. When you import modules, that code, the code that's imported, gets executed exactly once, and when that import happens, Python compiles the module's code, executes the code, and then populates the current module's namespace with the resource names defined in the module we imported. So what does all that mean? Well, let's have a look. Maybe I can do that. Here we go. Right, so let's say I'm going to call it chapter 8.py. One thing we could have done in the midterm is import a module called math, and that way we could have used the constant pi directly instead of having to define it like I did in my midterm.py file. Right, and then I can just run that, I hope, right, and it prints out pi to more significant figures than what I had in my midterm. So the key piece as far as modules are concerned is in order to get access to the math module, I need to import it into my chapter_8.py file. This is all stuff you probably should know. Functions, methods, variables, and modules should be snake case. Classes, on the other hand, tend to be camel case, right? Capitalized first letters with no underscores. Avoid using single letter variable names. Use comments, but use comments sparingly. And write test cases. I might have to have a separate video about writing test cases. Right, we've already seen how to import the math module, so it's just import module name. And once we've got that module in there, we can just access any part of the module using module name dot and then whatever part of the module we want. I only showed you .py previously, so we can do that. Another way I could have done that is from math import pi, I think, and then instead of having to use the prefix, I could have just done accessed pi directly rather than having to call it math.py. Depends on how complicated your program is. For complicated programs, it's usually best to not do that because the namespace can get a bit tricky. Sometimes different modules define things, the same named things, even though those things have the same name, they do very different things. Right, so I just did that from math import pi, and I could have called it something different. I could have said as pi, right? And that still works. So I changed the name of PI to the name PIE, and that works fine. When a module is imported, it checks whether there is a built-in module with the specified name. Otherwise, it'll check the sys.path variable, rather it'll check directories in the sys.path variable for the name that you're trying to import. Some of the standard things we could do are dir or help, right? So let's have a look at that, right? So right, there's the return from dir, and there's the return from help, right? And it'll show if I no, I have to import math, and then I can say help math.py, and that's a little over the top as far as it's just giving me help on the float object or the float type rather than pi itself. Right, so here's some of the modules that you might be wanting to use more often than others: string, math, unit test, sys, os, urllib, datetime, random, re for regular expression, intertools, and func tools. right? I'm not going to go into any detail on all of those. I suggest you have a look at them on the Python website. So, how do we make a package? Well, a package is just a directory, and with that directory there should be an init.py underscore underscore init underscore underscore .py. Doesn't have to have anything in it, but it should have it should exist. And here we're making a package called mytools, and mytools has a tokenizer.py and a calculator.py, and probably just an empty init.py. And then we can import calculator and tokenizer from mytools, or we can just import one of the modules, or we can import specific resources from the module. We don't have to import the whole module. Normally you're better off using absolute paths to import modules. You can use relative imports, which gives a directory path from the current directory to the directory where the module is located. However, that can be problematic if the directory structure changes and the directories move around level-wise or naming-wise. Okay, another useful thing to do in Python is to deal with files, and the way to do that is with the file object. Okay, so let's have a quick look. I think I made a file called example.txt. There it is. It's got 1, 2, 3, 4 on separate lines and then 100 on the last line. And what I can do is I can do something like I think it's file.open. No, let's try that. Ooh. Oh, it's just open, not file. Sorry about that. Okay, so now I've opened the file and I can read all the contents of the file, and there is all the contents of the file. Okay, we've got 1 followed by the new line character, 2 followed by the new line character, 3 followed by the new line character, 4 followed by the new line character, 100 followed by the new line character. I used RB plus as the mode. The mode tells you how tells Python how you're going to use the file. I just wanted to read the file. I didn't want to write the file. If I wanted to write the file, I'd use W or WB or W, maybe not WB plus. B means binary file. Doesn't really matter. Let's see what happens if I just used the other read mode. Right, so F equals open, and open, and I'm going to go example dot, oops, I need to put that in double quotes or single quotes. right? And I'm just going to read it in normal text mode, and I'm going to say contents equals f.read, and then print contents. Okay, so you can see the difference already. When I read it in standard text mode, it printed out what I had in normal readable text mode. Whereas when I opened it in binary read mode, it gave me the same thing. It read the same thing out of the file, but it interpreted it as something different. Right? Now I have a string, whereas let's see if I can do that, and then that. Right? It's a different thing, a different class. It's a class called bytes. It's not a class called string. Whether you use text or binary depends on what file you're trying to open. The other operation you probably want to do is to write a file, right? You might want to also close the file when you're done, right? So so I can write this file, and I'm just going to make it a text file. And then fw.close. Right, I didn't actually put in any new line characters, so it just wrote write to write 77. If you want to open a file and instead of clobbering what's in the existing file, you just want to add to the end of the file, you could open in append mode. So let's try that. Let's call it FA. FA equals open write this file, because I've already written the file, and we will, and then FA dot write, and I'm going to do that, and then this should be a new line. Oops. Okay. And there's the contents. I didn't clobber, whereas if I tried to just write the file, right, W2, and then do that, what was there before is now completely gone, and I've added a new file. That's the difference between write and append. You notice that I was calling the close operation. People forget to call close. So a much better way of doing things is using the with operation, right? So here we define the variable f as the output from the open call, And as soon as we leave the context of the with statement, so as soon as we stop getting indented here, that's the scope of the with statement, anything indented underneath the with statement. As soon as we leave that, as soon as we outdent and come to the same level as the with statement again, F will disappear and it'll have the close operation called on it. There are some specific file types that are good to use. CSV, JSON, XML, protocol buffers. CSV and JSON are probably the most useful. CSV is great because you can make a file that a spreadsheet can then read. JSON is great because a lot of computer APIs, application programming interfaces, send complicated data using JSON. XML is a little bit wordy. It used to be XML was what APIs used, but nobody used the advantages of XML, and JSON is much more human readable, so JSON won that fight. Protocol buffers is a really nice library or a really nice way to make binary data that is network efficient, or at least byte efficient. Google had to ship a lot of data around its internal networks, and they were finding they just had to use too much of their internal network shipping data. So they came up with protocol buffers to make it more efficient, and made it publicly available. So it's another nice way of doing things. CSV is you've got to import it, but then once you've got it, you can use the reader, you can use the writer, and it's pretty straightforward. Right? You can open the file for writing, and you can grab a writer from for the file, and you can write rows depending on how you want to write them. JSON is also good. Like I said, it's what a lot of APIs use. And there's json.dumps for encoding, and json.loads for decoding. It's dump s and load s. It's for converting a string one way or the other. Okay, we talked about modules, we talked about packages, we talked about files and reading and writing Python files. I didn't go too much into the detail of JSON or XML or CSV or protocol buffers, but they're there. I'm sure you'll come across them in some of the later assignments. Thank you very much.